Okay, so this first problem I want to hit on is a problem that one of the students asked for, and I appreciate it being asked. So in this problem, it's asking, it says an alloy is a mixture of metals. Suppose that a certain alloy is made by mixing 180 grams of an alloy containing 24% cotton or copper with 140 grams of an alloy containing 84% copper. Answer the question below and do not round. So for this problem, we will need a calculator to be able to do it. So we should get a calculator out and see if we can do this problem, okay? Okay, so the first thing that we know is it wants to know how many grams of copper are in the resulting mixture, okay? So if we're going to mix these two alloys, we want to know how much copper is in each, okay? So the first bit of information, and I'll highlight them in different colors. We have two alloys, right? The first one has this percentage and that many grams of copper, right? And we're going to mix it with one that has 140 grams with 84% copper. Okay, so in that first one, in alloy number 1, I'll call it, I'm going to have 180 grams times 0.24% so that I know how many grams of copper I have in alloy number 1. Does that make sense to everybody? We're okay? Okay, so then from here, I'm going to use my calculator. 180 times 0.24 will give me 43.2 grams of copper. Oh, all right. Alloy number 2 has 140 grams, but its percentage is 84%. And so I'm going to go 140 times 84%, right? So 140 times 0.84 gives me 117.6 grams of copper. Okay, so the first question is asking how much copper we have in the new mixture. So all we need to do is add these two. So I'm going to go 43.2 plus 117.6 results in 160.8 grams of copper. So this will be 160.8 grams of copper. Are we okay with how I found that? Yes? No?
Yes.
Okay. So then when we want to find the percentage, now it's going to be the total amount of copper, right? Because that's what they're asking for, over the total amount of mixture. So we know that the total amount of copper is 160.8, and then to find the total amount of mixture, it's going to be the 180 plus the 140. I believe that's 320, but I never trust myself. Yeah, it's 320. And then we're going to divide that. So 160.8 divided by 320 gives me 0.5025. But they're asking for a percent. So that means I have to multiply by 100. So the result ends up being, 50.25% of the resulting mixture is copper. We okay with that? I don't know if the person that asked for this one is here today. I don't think so. But this is the gist of how to do these problems. It's understanding and asking questions about what specifically they're doing. Okay. If that person comes back on at some point or is on, I can do more examples if needed. Does anyone need another example like from this area? By the way, this is the topic. We all right with this one? Can I go on to the next one, men?
Yes.
All right. So here we go. This topic is finding the absolute error and percent error of a measurement. So percent error, just so we know, is going to be percent error is, or we call it relative error, is the difference between the two divided by the initial amount. And then absolute error is just the difference between the two amounts. So in this problem here, it says Ravi is estimating the height of his building. The actual height of the building is 42 feet. Ravi estimates it to be 45 feet. Now, we want to find the absolute error. And so absolute error is simply going to be the absolute value of the measured minus the expected. Okay, and so the way we can do this is the measured will be his estimate, which was 45, minus what it should be is 42. And so his error was 3. So the absolute error is going to be 3 feet. Are we okay with that?
Yes.
Okay. Now, when we go to find the percent error is going to be the absolute error over the actual times 100. So it's absolute error over actual times 100. So that means I'm going to get 3 feet over 42 times 100. I'm good, but I'm not that good. And so his percent error, I should have put that. That's percent error is this. Ends up being 7.14286%, but we usually don't write it that much. We could go with 7.14%. Now, notice something about relative error. Does relative error tell us if he was overestimating or underestimating? It's an important idea. Does it make sense what I'm asking? So this 7% error that I have here, right? Do I know it to be an overestimate by Ravi? Or do I know it to be an underestimate if I just look at the percent error? What do you think?
Over.
So I wish it would tell us, but it doesn't. Because of the absolute error being used, because we use the absolute error and percent error, it just tells us how much he was off by. He was off by 7.14%. It doesn't tell us if it's over or under. There's one that we can use, which is called relative error. And relative error doesn't care about always being positive, it is just measured minus expected. Or if you want your guess minus the actual. So it would have been, he guessed 45 minus 42. So his error was 3. Relative error tells me now he was overestimating by 3. Does that make sense?
Yes, got it. Thank you.
Yeah. If you have relative error and he would have said it was 38 feet, then you would have gotten 38 minus 42, and that would have been negative 4 feet. You would have known, oh, he underestimated. And then when you do percent error with that, you know if you're over approximating or under approximating. Does that make sense, the subtle difference between those?
Yes.
Okay. Let me do the next one. Now we're going to talk about compound interest, and I'm going to do it in a way that's a little bit easier for you to understand. You will need a calculator, so I strongly recommend that you guys have one. So let's look at this problem. It says, suppose that Joe borrows $6,000. So now he's in the hole $6,000 at an interest rate of 8% compounded each year. Assume that no payments are made on the loan, and that's important because if you pay down the loan, the interest rate won't be the same every time. So they're saying he's just borrowing money and not paying it back. Okay, so it says, find the amount owed at the end of the first year. So we know he's going to owe $6,000 because he made no payments, right? Plus he's going to owe, so this is the original amount, plus the interest, right? And the interest, the way we find the interest is that 6,000 times 0.08%. Or I'm sorry, 0.08 or 8%. Okay, so that gives me 6,000 plus 480, which tells me after the first year he owes $6,480. Okay, and since it's going to be compounded the next year, at the start of the next year, how much money does he owe? What do you guys think? Isn't this what he owes at the start of the second year? Right? Because that's the amount at the end of year 1. So at the start of year 2, he doesn't owe $6,000. He owes $6,480. Does that make sense to everyone? Yeah? All right, so this was first year. So second year, again with no payments, it's 6,480 plus 6,480 times the percent is going to give me 6,480 plus 518.40, and so his new amount owed is $6,998.40. So that's after 2 years. So you can see something important here about this type of problem. In real life, when we're talking about borrowing money, you want to pay it off as quickly as possible. Because if we just look at this problem really quickly, if you bought something for $6,000 and didn't make payments at 8% for 2 years, you've basically made that item $1,000 more expensive than what it originally was. Is that a good thing?
Never.
It's never a good thing. I always tell my students, always live on less than what you make. In fact, there's a great class that I recommend you all take. It's called Math 150. And in that class, we show students how to invest. Do you know if you're 18 years old and you invest $50,000? I'll actually do the math for you guys. I did this for my class because I wanted them to know. I need my other calculator. It ends up being, if you invest $50 a month from the time you're 18 till you're 65, you'll have about $600,000 saved away. And $50 really, it's a good chunk of change, but how many of us spend $50 on things that we don't really need, right? So it's something that could be useful to do that can help you in the future. Math 150 though, it's a great class. I taught it for 2 semesters, and then unfortunately I got pulled away from it, but I really like the class. They show students how to buy homes, how to buy a car, so you know how much the car is actually going to cost. Not the price that you get on the sticker, but after interest and everything. Show you how to make a budget, all kinds of things. It's a really cool class. Sorry, tangent, but it's a good class. Okay. Now here, when we want to estimate a tip for a dinner that's $59.62, by first rounding the bill amount to the nearest $10, here's how we do this. So if we're going to round this is the amount that our bill is, right? So if we're going to round this to the nearest $10 amount, what's that going to become?
$60.
It's going to become $60, okay? Now for me, 15% is kind of a funny number. So typically what I do is I go like this. I think of it as 10% and 5%. So if I can do the 10% one, I know that the 5% is just half the amount. Does that make sense? Does that make sense what I'm saying? 5% is half of 10%. So I know I can do this math easy. 60 times 0.1 plus 60 times 0.05. I know this one here, 0.1 is just move the decimal 1 over, so that's $6, right? And 5%, because I know it's half of that, has to be how much? What's half of 6?
$3.
I feel like I'm talking to myself. So the tip for this bill should be about $9. Does that make sense what I'm saying? So whenever I go out to restaurants, so let's say I have a $50 bill and I want to give a 20% tip, what I usually do is I just go, okay, I'm just going to go 50 times 0.1, which I know is just move the decimal 1, so that's 5. But if I want to do 20%, that means I've got to double that 5, correct? Because 20 is double 10. So my 20% tip would be $10. Does that make sense how I'm doing that? Is anybody out there? Is it just too early today?
Yeah. Yeah.
Okay. Well, I'm trying to do this so that it's beneficial for you. But it gets a little bit hard because I do need to see if you guys understand what I'm doing and talking about. So if you respond back, that's beneficial for the whole.
Can you do one more example?
Like this one?
Yeah.
Sure. So if I gave you a dinner bill, let's say your dinner bill was $75, okay, and 25 cents, okay? And I wanted to give a tip of 15%, right? This is the tip I want to give. Now, instead of just guessing or writing whatever I want, the first thing I'm saying is let's round it to the nearest $10 amount. They want to round to the nearest $10 amount. So what's that 75.25 going to become?
Is it 80?
To 80. So we're going to say,
Yeah.
okay, that's going to be $80. So we're obviously going to tip over 15% because we rounded up our bill, right? Now, whenever you're going to do 15, so 15%, you agree with me, is 10% plus 5%, right? Okay, 10% is always easy to do because all I do is move the decimal one spot to the left. So what's one spot to the left of 80?
8%?
So here, if I'm at $80, right? 10%, 10% tells me to move the decimal one to the left. That's what 10% tells me to do every time. So what would 10% be of 80?
I'm kind of confused. I'm not gonna lie.
Okay, no
I'm
problem.
half asleep.
So look. So you look at anytime you multiply by 10%, okay, by a decimal point one, you're gonna move the decimal one to the left. So look, if the decimal is here and I move it one to the left, what's that dollar amount?
It's $8.
$8.
Yeah.
Does that make sense? By just moving the decimal one, and that's every time you multiply by 10%. So if I gave you $10,452 and I said multiply that by 10%, where would the decimal go?
On the left.
Yeah, between what two numbers?
0 and 4?
No, so it's cool. So that if the decimal's here and I multiply by 10%, I only move it one decimal spot. One spot. So it's
always
gonna go
one.
Yeah. If I multiplied by 100%, if I multiplied by 100%, then the decimal would move. It wouldn't move at all. But every time I multiply by 10%, I'm moving the decimal one spot. Okay? So in 80, I'm just going to move it one spot. Now, I can show you mathematically too if you want to see it. So if I went 80 times 0.1, what's 80 times 0? I'm sorry. What's 1 times 0?
0.
Okay, what's 1 times 8?
8.
Okay, see how the decimal's right here? How many spots are behind the decimal? How many numbers are behind the decimal?
1.
There's 1, so I gotta have one number behind the decimal. And so that makes it 8. But instead of thinking about that way, just move the decimal 1 to the right, or 1 to the left. So when we go to do the tip, it's going to be 80 times 0.1 plus 80 times 0.05. Okay? And you said 80 times 0.1 is $8, correct?
Mm-hmm.
The other one is half the amount, right? Because one was 10% and the other was 5%. So it added up to 15, right?
Yeah.
Okay. So if this is $8, this is half the amount. What should this be?
4.
That's right. It should be 4. So our tip on an $80 bill should be $12. You want me to do one more?
Yeah, just to.
No, for sure. No
Happy.
worries. No worries. Okay, so let's say we had a bill that was $68.32. That's our dinner bill. And we want to tip again 15%. What should I round it to?
70.
70. Very good. And then our tip is 10% plus 5%, right? Just to make life easy. So what's the 10% tip going to be?
$9.
No, what's the 10% going to be? How many spots do I move the decimal?
1.
So what's it going to be?
$9.
Oh, this is a 7. You might be...
Oh.
Right? Because it's
7.
68. You said it was 70. Sorry. I had that little loop in it, right? So it should be 7. Sorry, my bad. And then what's half of 7?
350.
Right? So when we add this,
Yeah.
what should the tip be?
$10.50.
$10.50. I'm half asleep right now. I'm trying to get waking up.
No worries. No worries. I apologize for
I'm
that.
getting it now. I'm understanding it, pretty much.
You got? Do you want me to do one more just in case?
No, I got it.
You sure?
I wrote everything down already. Pretty much. I got it.
Okay.
If I do have questions, I'll just.
Yeah, please ask. Please ask. Yeah. There was one question about tens then, because those are the topics I was going to talk about today. What is the question that you had? I think it was Jay, wasn't it?
I think it was something with the power of 10 that they asked.
Or Jared, I think is who it was that would ask. Yeah, something in the power of 10, but that makes it hard for me to find the topic. Something.
Yeah, struggling on it's on Alex. That was power of 10.
Okay. Was it multiplication of a decimal by a power of 10?
I think.
Or is it division by a decimal by the power of 10?
I think it was a decimal. I'm not 100% sure. I'm looking now.
Because well, I'll do one of these just to start, and then I'll do the multiplication one.
Yeah.
And then we can go from there, okay?
All right.
Okay. Okay, so this is kind of like what we were just doing with the 10%. So this is, the topic here is multiplication of a decimal.
So, Professor, I found it. It's word problems with the power of 10.
Oh, word problems with the power of 10. Okay, that's cool. Let me go back and find that one. Word problems with the power of 10. Word problems with power of 10. Here we go. Cool, I found it. Okay, so here it is. This is the topic. Okay, so here we go. this problem says the volume of 10,000 drops of a liquid is 10 fluid ounces. Okay? The question is, what is the volume of 100 drops? Okay. So the way that I'm going to try to touch on this is we're doing a comparison of drops to fluid, right?
Yeah.
So if we're doing a comparison of drops to fluid, it says 100 or 10,000 drops to 100 drops should equal 10 ounces to how many ounces? Does that make sense the way I'm doing it?
Yeah.
Okay, so when I do this, then what I can do is cross multiply, right? So I'm going to get 10,000 times x is equal to 100 times 10. Agreed?
Agreed.
Which is going to give me 10,000 times my variable x for my number of ounces times 1,000 or equal to 1,000. So then x is going to be 1,000 over 10,000, which should be 1 over 10. Or we can say that's 0.1 fluid ounces. Does that make sense?
Okay. Yeah.
Do you want
Starting
me,
to make sense.
do you want me to do another one? I can do a different example.
Yes, please.
Okay. Okay, so here's this next example. It says the weight of 100 identical samples, and that's important because that's saying that they're all equal in weight, right? Of some substance is 0.01 pound. What is the weight of 10 samples? Okay? So, the ratio again for this should be set up in a way that I have 100 samples to 10 samples should equal 0.01 to I don't know. Does that make sense? So what I'm doing is I'm going sample to weight and then sample to weight. Agreed?
Yeah.
And notice something about this that's important that I didn't talk about in the previous problem. The top number is the information that we know for each. So it's for 100 samples, it weighs 0.01 pounds, correct?
Correct.
2, the bottom number being the sample with the weight that I don't know. So it's known to unknowns. Does that make sense?
Yeah.
So when we cross multiply, I'm going to get 100x is equal to 0.01 times 10. So that's going to give me 100 is equal to 0.1, which will then equal 0.1 divided by 100, or x is going to equal, moving the decimal 2 spots, 0.001 pound.
Okay.
You feel like you got it?
Yeah, I think so.
Okay. Are there any other questions that anyone might be struggling with? Any topic that you'd like me to address? We have some time, and I want to be able to help you guys as much as possible. How is this module coming? Module 3.
It's pretty tough, but
A little hard.
yeah,
It's a little bit harder.
yeah.
Okay. Are there any that you'd like me to address?
I'm trying to figure out. I have one in mind, but I can't. I'm trying to think of it. It's with the scale, like the numbers line on the line. Oh, I forget the name of it.
Okay, so it's some sort of scale problem.
Yeah.
Okay, let me see if I can find something. Is in the topic name the word scale?
I'm not sure,
Okay, let me.
but it has a chart pretty much.
Okay, one of the things that all of you can do to help me when you are having problems with any of these, if you could just write down the topic, I can just hit on those topics for you to explain them so that you guys can understand. Just because I think that makes it easy for me to find the topic, and then I can help you. So let me see. It's something with a number line, you said?
Yeah, I'm trying to find it right now.
Okay.
Understanding the decimal, something like that.
Understanding the decimal? Okay. Let me see. Oh, understanding decimal position on a number line?
Yeah, that I don't know why. I was just having a hard time.
Okay, no problem. No, this is actually kind of tough stuff. People underestimate some arithmetic. It's tough. So don't feel bad. Okay, so here is a problem. Stupid phone. Okay, so this topic is, it says understanding decimal position on a number line using zoom, and then what they mean by zoom is zooming in under the hundreds. I'll do, okay? Thousands is going to be basically the same thing. So what they're showing is a number line, okay? Here's 8, and then they have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, and here's number 9. And the number is right here, right? So we can't truly tell what's going on. So I'm going to do this so you can see it. Okay? Now watch this. Since how many lines are in between 8 and 9? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, right? To get to 10. So that tells me that each one of these lines is a tenth. Okay? So this is 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, Do you agree with that?
Yeah.
Okay. So now that we understand that, I'm going to zoom in. Okay. So I'm going to zoom in. And this is 8.8 and this is 8.7. Okay? And then what I'm going to do is I'm going to put lines in between there. And I'll do 9 of them again. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we said that it was 0.9, right? Or I'm sorry, 9 lines was 0.1 when it was whole numbers, correct?
Yeah.
So each line each line here was 0.1 when they were whole numbers. So we moved the decimal one spot for each line. So it's 0.1, 0.2, 0.3, 0.4, 0.5, right? But now in this one, we're already in the tenths. So the lines in between there, instead of being tenths, they're going to be hundredths. Does that make sense? I'm going to move the decimal one more spot. So this becomes 8.71, 8.72, 8.73, 8.74, 8.75, 8.76, 8.77, 8.78, and this one's going to be 8.79. The next one would get me 8.8. Does that make sense?
Yeah.
So where is my dot?
8.78. No, 8.77.
That's it. So my dot is at 8.77. So it's, you know how they show you the picture of them zooming in and zooming in?
Yeah.
That's what they're doing. But you need to figure out by counting how many lines are in between, if it's 0.2, 0.4, I mean, what, 0.2, 0.4, what am I talking about? You need to decide if it's by tenths, is it by what number they're doing. Here, let me do another one. Let's see if they always do it by tens. Probably do. Yeah, they're pretty much always doing it by tens. So here's another one. We'll just see if we can do it together. So here's 8. Here's 9. 9 lines in between. So if there's 9 lines in between, how many, what does each one represent?
Say again?
If there's 9 lines in between the whole numbers, what does each of those dashes represent in terms of moving over?
I'm not sure.
Okay, just so you know, to get from 8 to 9, how many times did I have to skip? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means each one of those lines is a tenth. I know that's a little kiddish, but that's the way I would show my kids to do it. I'm like, look, how many times do you need to skip? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since I jumped 10 times, that means that's got to be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. I've added 1 to 8. Does that make sense?
Yeah.
Then my point, let's say my point is right here. Okay, so we should label what these two are so we know where our dot is between what two specific numbers. So between what two specific numbers that we know is that blue dot.
Eight 8.7.
Right? 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7. So I know this is 8.6, this is 8.7. Does that make sense?
Mm-hmm.
Okay, then from there, I'm going to zoom in on that. Here is 8.7, here is 8.6, and then again I'm going to do 9 lines. Okay? And I'm going to put my blue dot right here. Now, how many jumps did I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that the number that follows the last digit is going to be 8.61, 8.62, 8.63, 8.64, 8.65, 8.66, 8.6. 8.67. So this is 8.67. Does that make sense?
Yeah.
Does it?
Yeah.
Okay, so can I give you one and then you tell me what it's going to be? Oh, we got to try it, right? Let's see if we can do it.
All right.
No worries if you get it wrong. The whole point is, let's see if we can learn from this, okay?
Yeah.
All right. So let me see what they're going to give me. All right, cool. Okay, so here's what I want you to tell me. What two dashes, what are the numbers between the two dashes for the blue dot?
It's wait. .2 and 5.3.
Solid. That's 5.2,
Yep.
that's 5.3. That's perfect.
It's 5.24.
Perfect. You got it.
Yeah.
You got it.
I want to know how you get the dot to there. That's what I'm trying to figure out. I knew the answer. I'm just trying to figure out like, how you zoom. You know how you zooming in more and more.
Yeah.
How you get the dot to there?
Okay, so
To
let
that
me
line.
show you. Let me show you on my computer real quick. Okay.
That's how I was getting confused a lot. I was like, how did you get that line?
Yeah,
to
no
there?
worries, no worries. I'm going to show you right now, okay? This is what the problem is going to look like. Do you see that?
Yeah.
So first they give you this piece, and that's where you get, okay, it's between 5.2 and 5.3. then the next piece is, okay, here's this. Now they've zoomed in. So this number is 5.2. This number is 5.3. Can you see my mouse?
Yeah, I see it now.
But do you see my mouse on there moving?
Yeah.
Okay, good. So then if this is 5.2 and this is 5.3, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10. So then I know I'm going to go 5.21, 5.22, 5.23, 5.24. Make sense?
Yeah, I got it now.
Cool.
I got it.
Any other questions from anyone? Anybody?
I had the other one, but I can't even find it.
Okay, so do me a favor then. With all of these problems, whenever you have an issue and you're like, oh, I can't do this problem, just write down the topic. You guys know how to see what the topic is, correct?
Mm-hmm.
Is there anyone that doesn't know where to find the topic? I can show you real quick. I'm just going to show you just in case. Okay. For everybody, this blue is the topic. So if you get stuck, this is what you want to write down for me. Word problems on proportions, problem type 2. Like if this is what you get stuck on, write this down, and then when we come to class, I can do those specific types of problems for you, okay?
Yeah. Okay.
Okay?
Mm-hmm.
Okay. Cool. Well, if there are no more topics, any questions for me, then I will let you.
Sure. I have a question. It's on the test too. By accident I send you some a way how you wanted us to write our answers.
Yeah.
On a paper or something. I sent it to you, but it didn't send. I sent it to the wrong. It was weird. I sent it to you, but it didn't send completely to you. And I didn't send it to the right email. You could say.
Yeah. Well, what you can do is just forward that email to me.
Yeah, I sent it when the day happened, but I went back to see if I was just curious, and it didn't send. It
Yeah,
wasn't
no problem.
The same email.
Just forward me that
All right.
email that you sent. That way I have the timestamp of when you sent it, okay?
All right.
Okay.
Oh, just forward?
Yeah, just forward it to me.
All right.
All right. Well, if there's no questions, then I'll let you guys go so you can hop on Alex. One of the things that's still very important to me, if there's anyone who's having any issues with Alex or needs any help with Alex, please talk to me. Because there's no way for you to be able to pass this class because you can't take the exams, you can't do any of the work to be able to learn the material. So please reach out to me so that we can talk about how I can try to help you so that you can get that work done. Okay? Because withdrawal dates are coming up, and like I want to give you the best opportunity possible to pass this class. Okay? All right. Well, I'll stop recording.